Welcome back. Today, we're going to pull back the curtain on one of the unsung heroes of networking, DHCP4. We'll break down how it works, how you can actually configure it on a Cisco IOS router, and, maybe most importantly, how to prove it's doing its job. All right, let's get right into it. Seriously, think about it for a second. You walk into a coffee shop, you flip open your laptop, connect to the Wi-Fi, and bam, you're online. You didn't have to punch in an IP address or a subnet mask or a gateway. So how in the world does your device get all that crucial information so fast? Well, the answer is DHCP. Back in the day, network admins had to do everything by hand. We're talking spreadsheets to track every single IP address. This static approach was just a nightmare. It was slow, you'd get typos, and it just couldn't scale. Dynamic addressing with DHCP completely changed the game. It's an automated central system that hands out a whole connectivity profile. Not just an IP, but the subnet mask, the default gateway, and even the DNS server, the whole shebang.
So, how does this automation actually work its magic? Well, it's basically a very structured four-step conversation between your device, the client, and a DHCP server. It's a process we know by the acronym DORA. And this DORA process, that's discover, offer, request, and acknowledge, is the fundamental handshake that gets your device onto the network. Trust me, you're going to want to remember that one. So let's see how this little chat plays out.
I love this visualization because it really shows the back and forth. First, the client, who doesn't know who to talk to, just shouts at Discover broadcast out to everyone. A DHCP server hears this and sends back an offer with an IP address. The client then broadcasts its request for that specific offer, which also kind of tells any other DHCP servers, hey, thanks, but I'm taken. Finally, the server sends a final acknowledgement to lock it all in and provide the rest of the network details. It's a super clean and efficient negotiation. Now, here's a really crucial point. Your device doesn't own this IP address, it's just leasing it. Think of it like borrowing a book from a library. The lease has an expiration date. And this is actually a subtle security point, right? In a busy coffee shop with people coming and going, you want short lease times so those addresses get recycled quickly. In a corporate office, longer leases are probably fine. If an address isn't renewed, it goes right back into the pool for another device to use. So incredibly efficient. All right, that's enough theory. Let's translate this into practice and actually get our hands dirty configuring a DHCP server on a Cisco router right in the command line. The workflow is actually a pretty logical three-step recipe. First, we're going to set aside or exclude specific addresses we want to reserve. Second, we'll create the pool of addresses that can be handed out. And third, we'll define all the other goodies, like the gateway and DNS, that will be given out along with the IP. Okay, let's look at the actual commands. We start with IP DHCP excluded address. Now, this step is absolutely critical, and you have to do it before you define the pool. Why? To prevent the DHCP server from accidentally handing out an IP that's already being used by something important, like your main router or a server. Once those static IPs are safe, then you can create your address pool with the IP DHCP pool command. Now for the good stuff, the payload. Inside the DHCP pool config, we define the network, which tells the client what subnet it belongs to. We set the default router, which is its ticket to the internet, and we provide the DNS server, which lets the client turn names like google.com into actual IP addresses. This is the complete package a device needs to get up and running.
So we've typed in the commands, but are we done? Not even close. In networking, if you didn't verify it, you didn't do it. So how do we confirm our DHCP server is actually up and running the way we want it to?
Our first tool in the toolbox is the show IP DHCP binding command. I like to think of this as the server's live lease ledger. It tells you who has what right now. And when you look at the output, you can see exactly which IP address is leased to which device by its unique hardware MAC address. It even shows you when the lease expires. This is your #1 go-to command for tracking down who has what IP on your network. Next up is what I call the server's health check. Show IP DHCP server statistics. This command tells us if the server's actually having those DORA conversations we talked about. Right here, you can see the DORA conversation in action. These counters track every single discover, offer, request, and acknowledge message. If you see these numbers ticking up, you know your server is alive and kicking. If they're all stuck at 0, well, you know you've got a problem somewhere in that initial handshake. Okay, so far, we've kind of assumed that the client and the server are on the same local network. But in most real-world networks, servers are centralized somewhere else, and clients are on all these different subnets. And that creates a big problem. So here's the issue, what we can call the broadcast barrier. That initial DHCP discover message from the client is a broadcast. It's shouting to everyone. But routers, by their very design, are meant to block broadcasts. They don't forward them from one network to another. So the client's cry for help never even reaches the DHCP server over on the other subnet. But the fix is surprisingly elegant, the IP helper address command. You configure this on the router's interface that's facing the clients. It basically tells the router, hey, listen for those DHCP broadcasts, and instead of just dropping them, repackage them as a nice targeted unicast message and forward them directly to the DHCP server's IP address. The router becomes a helpful little relay agent, bridging that broadcast gap. Now, let's connect all these command line concepts to the hardware you probably have sitting in your own home right now. It's kind of funny to see the roles reverse here. Your home router, which acts as a DHCP server for all your laptops and phones, is also a DHCP client on its other side. It has to go out and ask your internet service provider for its own public IP address. On a Cisco router, the command for this is super simple. Just IP address DHCP on the outside interface. And if you've ever logged into your home router's webpage, I bet you've seen this. That setting for internet connection type, where you pick automatic configuration DHCP, that's just the user-friendly graphical version of that exact same IP address DHCP command. It's the same principle, just with a prettier face. So let's boil this all down. What are the key takeaways? For the protocol itself, just remember DORA. For setting up a server, always follow the exclude, create, define workflow. And for building bigger networks, use the IP helper address command to act as a relay agent. If you can master those three things, you've pretty much mastered DHCP.
You know, DHCP is the perfect example of a protocol that just works, automating a really complex task that's totally fundamental to our daily lives online. It really makes you wonder, what other invisible automated protocols are out there, silently running the internet that we rely on every single day? Something to think about. Thanks for tuning in.